So this is problem 11 of the aiming. Let Mn be the n by n matrix with entries as follows. For I between 1 and n, m sub I is equal to 10, which is basically just the diagonal entries. And for I between 1 and n minus 1, m sub I plus 1 comma I equals m sub I comma I plus 1 equals 3. All other entries in m sub n are 0. Let D sub n be the determinant of matrix m sub n. Then sum from n equals 1 to infinity of 1 over 8d sub n plus 1 can be represented as p over q, where p and q are relatively prime positive integers. Find p plus q. So the first matrix is just 10, and the determinant of that is 10. The second matrix is 10, 3, 3, 10. The determinant of that is 10 times 10 minus 3 times 3, which is 91. And then the 3 by 3 matrix is 10, 10, 10, 3, 3, 3, 3, 0, 0. The determinant of that by cofactors method is 10 times the determinant of this stuff, which is 91 from determinant 2, minus 3 times basically 3 times the determinant of 3, 3, 0, 10, which is 30 minus 3, 27. Or 3 times, no, 30 minus, so 3 times 30, which is equal to 910 minus 90, which is 820. Now, of course, we're looking for a pattern between the determinants, but there's not an obvious one. So we'll plug it into the term of the sum. So 1 over 80 plus 1 equals 81. 1 over 8 times 91 plus 1 equals 1 over 729. And then 1 over 8 times 820 plus 1 is 82, 164, 328, 656, 650, 65, 61, right? And this, you can tell that this number is 9 times this number, and this number is 9 times this number. So we're thinking that this is a geometric series whose common ratio is 1 over 9. We'll verify that by looking at one more matrix. 10, 10, 10, 10, 3, 3, 3, 0, 0, 0, 3, 3, 3, 0, 0, 0. So then the determinant is 10. D4 equals 10 times the determinant of this matrix here, which is just D3, which is 820, minus 3 times the determinant of this matrix, which is basically 3 times the determinant of this 2 by 2 matrix, so that is D2. So 3 times 3 times 91. So this turns out to be 8200 minus 819, which is 7381. 81, right? So 7381, and then if you multiply that by 8, you get 8, 64, 30, 8, 59, and then you add 1, so this becomes 59049, which if you check is 9 times this. So we can reasonably guess that it is a geometric series whose first term is 1 over 81 and whose common ratio is 1/9. So the sum would be 1 over 81 times 1 over 1 minus 1/9, which is equal to 9/8 times 1 over 81, which is just 1 over 72. And so the answer is 73, the sum of the numerator and the denominator.